I would like to show you the laws or properties of exponents, of powers, but before I do that I want to refresh your memory on what a power is, because I think if I explain to you actually how to come up with the rule, it'll be easy to remember. So the first one here I'm going to show you is two powers with the same base, the product multiplication of two powers with the same base, the big number, the x. The x is the same. So what do I do with the exponents? There's actually a rule for that, but to show you, because I actually forget from year to year what the rule is, so here's how I come up with it. I picture what this looks like, x to the fifth power. That's x times x times x times x times x. That's x to the fifth power. The power tells you how many times to multiply the base by itself. Okay, times x to the third power, which is x times x times x. Okay, since it's all the same base, I'm multiplying x by itself. 1, 2, 3, 4, 5, x to the fifth power, 6, 7, 8, total of 8, x to the eighth power. Okay, so what do I do with the exponents? When I am multiplying two powers with the same base, I'm actually adding the exponents. 5 plus 3 is 8. So I'm going to find the sum of the exponents. Alright, my next example is what to do when I have a fraction, a quotient of two powers with the same base. Alright, I'm going to picture again what this looks like. X to the sixth power means on top in the numerator I have x times x times x times x times x. I have 1, 2, 3, 4, 5, 6 x's. In the denominator on the bottom I have x squared, so that's x times x. Now anytime I have common factor on bottom and top, they make 1. X divided by x is 1. So these will cancel out and these will cancel out. So when I have a fraction, the question that I'm asking myself is, where do I have more? Okay, in this situation I have 6 on top, 2 on bottom, so I have more on top. And then I ask myself, okay, how many more? And that means I'm going to subtract. I have 1, 2, 3, 4 left on top. 6 minus 2 is x to the fourth. And I had more on top, so that's where they're left. That leaves nothing on the bottom, so I'm going to hold that place with a 1. Now anything divided by 1, it doesn't change it. It keeps its identity. So this is just x to the fourth power. So again, what did I do? When I had powers of the same base, I subtract the exponents when I'm finding the quotient. Okay, my next example is, what do I do when I'm taking an exponent of a product? So first let's look at what that means. So in the parentheses I have 7 times x cubed, which is x times x times x times y. And I'm taking that whole product and squaring it, so I'm multiplying by itself. 7x cubed times y. Okay, well this is all one big product now. I don't need these parentheses, so this becomes 7 times 7, which is 7 squared, which is 49. X cubed times x cubed, which gives me a total of 1, 2, 3, 4, 5, 6 x's, x to the sixth power, and then y times y, so that's y squared. So what did I do with these exponents? Well, first of all, I want you to understand that if you don't see an exponent, and the most common mistake is forgetting this constant in front, the 7. If I don't see an exponent, it has an exponent of 1. Okay, so this is 7 to the first power times x cubed times y to the first power. So what am I doing with these exponents? Well, I'm going to have 2 of this 1, 7. So 2 times 1 is 2. So 7 squared, 49. 3 times 2 is 6. I have 2 sets of 3, so that's 3 times 2 is 6. X to the sixth power. And then 1 times 2 is 2, so y squared, y to the second power. So what I did with the exponents is I multiplied. So really what I want you to think about when you see parentheses is think about distributive property. We know that's multiplication. We always multiply when we have parentheses and we're distributing something. Okay, The next example is, what do I do when I have a negative exponent? Alright, well, to understand what that means, I need to make this a fraction. So x to the negative fourth power, if it's not a fraction, I can make it a fraction by putting it over 1. So what does a negative exponent mean? This is the hardest one for me to understand, so it's one of the first things I get rid of when I'm doing these problems. A negative exponent means you're taking the reciprocal. So since x to the negative fourth power is in the numerator, it's going to move to the denominator and have a positive power once it moves. Now I have nothing left on top, so that's going to become a 1. Okay? So what do I do when I have a negative exponent? I take the reciprocal. Alright, and my last example here is what to do when I have a exponent of 0. This is actually the easiest one. Anything to the 0 power is 1. Everything goes away. It just becomes 1. Always, if the exponent is 0, your answer is always 1. Okay, and if you forget this, just put any number to the 0 power in your calculator. You're always going to get 1. So let's go back through these real quickly. If the base is the same and you're multiplying, you're finding the product of two powers with the same base, you're going to add the exponents. 3 plus 5, I'm sorry, 5 plus 3, it's commutative. 5 plus 3 is 8. Okay, if you're finding the quotient, if you're dividing two powers with the same base, you're going to subtract. 6 minus 2 is 4. You're going to subtract the exponents. If you have parentheses, you've got a product in here and the exponent is on the outside. Just like any time you distribute, you're going to be multiplying. Okay, you're going to multiply the exponents. Don't forget the coefficient. If you have a number up front that has a power of 1, so 2 times 1 squared, 7 squared, 49. 3 times 2, 6. 1 times 2, 2. Okay, so you're multiplying exponents when you have parentheses. If you have a negative exponent, if it's on top, it moves to the bottom. If you have a fraction where the negative exponent is already in the bottom, if it starts in the bottom, it goes to the top, to the numerator. And then the easiest of all of them is the power of 0. What do you do when you're taking something to the 0 power? It's always 1. No matter what it is, it's 1. All right.